So first of all, welcome to our Hackathon participants, to your first workshop of the Solana Hackathon. I hope you're all enjoying it so far. And please do reach out to myself or Patrick on Discord or by email if you've got any questions about the hackathon. We have a second group with us today, which are the participants in our Solana bootcamp. So apologies for this break from your sort of regularly scheduled programming, but we're really happy to have you here. So before we kick off with the workshop, I'd like to just invite JP from Código to come up and share some news about bounties with us.
Hey, Dan, thank you. Welcome, chat developers. We're going to take you through a workshop that's going to take you from zero to deploying a dApp, in this case, a DeFi dApp, in an hour. As you go through it, I want you to think about what it would take you to do it manually otherwise. But I want to congratulate Vivek, one of you, who actually was the first one to complete this workshop ahead of time. He did it yesterday based on a document, a step-by-step document that we published that should give you the confidence that this is totally doable. If you get lost as you go through the workshop, just make sure that you go back to the document and you should be fine. Everything is completely detailed there. I want to announce a new bounty. So there's a new bounty for talking about the workshop on social media. The details of that bounty will be communicated to you through the amazing team at Encode. We're also going to put it in this chat. We'll put it on Discord. We'll put it there, so you'll find it. And just rest assured that there's no urgency. The deadline is January 31st. So make sure if you enjoy the workshop that you follow us on Twitter and that you check out that new bounty. We want you to talk about it. Without further ado, I hope that you will enjoy the session with our head of engineering, CIDL, and I want to pass it on to him to just get started as soon as possible.
Hello. Perfect. So let me share the screen. Thanks for coming to the workshop. My name is Jaciel Guerrero. I'm part of the Código engineering team. So let's get started. Okay, so we already shared this document. I'm going to the workshop basically follow the entire document and of course adding additional detail and information so you can get up and running and build and deploy a dApp in less than an hour. Any question that you have, you can make it in the chat, and Soham, our DevRel from Código, is going to be taking those questions, and at the end, I'm going to be responding. I'm going to be addressing those questions. Also, if Soham can share this document in case anyone doesn't have access yet. And from the workshop, from this document, the first step is to access Código Studio, and for that, we're going to go to the link studio.código, and let me share it here in the chat. So here we're going to enter Código Studio, and you can register with a email. So here, when you enter at the end, you have register. You can click on it and specify your information and then register. Or you can authenticate using your GitHub account and you can also access. The first time that you access Código Studio is going to take like 3 to 5 minutes because what is happening is that it's going to provision an environment, a web-based IDE for yourself where you will have all the dependencies for Solana, Encode, Node.js, Browse, so everything's going to come pre-configured for you and we can start immediately writing on the CIDL. So let's take 1 or 2 minutes to verify that everyone have access to it and then we can start following along on the workshop. And if you have any issue, you can write it down in the chat and Soham can give you any support. And while you are accessing, let me just explain what we're going to be building. So basically, we're going to build a simple DeFi application where we have one a lending application when we have one lender, a person that's going to be lending money, and we have multiple borrowers. In different countries may be known as informal lenders. Perfect. And basically here we are going to create all the data structure to store the capital, the money that we are going to be lending. After that, clients can request some loans, and me as the lender, I can approve those loans, and it will be transferring their money. We're going to be using the Solana native token SOLs for the transferring, but we can expand the feature of this use case to use other types of tokens. So let me check quickly the chat if everything is going okay with the sign up. Perfect. So I have seen that some people have signed up. Okay, so let me give one other minute before I start on the implementing. And here one quick question is, what does the CIDL mean? CIDL stands for Código Interface Description Language, or Código Interface Definition Language. So it's a natural language, an IDL, where we're going to be specifying the interface of our contract or of our Solana program. So basically we're going to specify the data structure and the instructions, the methods of the contract, and from here we're going to use this CIDL to pass it to the generators, to the Código generators, and this is going to produce a full production ready Solana program and a 100% of the code for the client library. And we're going to see all that step by step. Okay, so now I'm going to start here in the workspace. I have already signed up, and when you enter, you most likely will get a directory that says lost and found. You can delete the lost and found directory, and also it's going to open with the get started, so you can also close this. So we want the blank slate here in the VS Code. And the first step for the implementing is to create a CIDL file. So I'm going to go to my file explorer. If it's closed, you can open it here in the icon for Explorer and right click new file. Here I'm going to type CIDL.yaml. The file doesn't need to be named CIDL, but it's easier to track that way, and it will be created in my workspace. Okay, so here it has created my CIDL file. Now I need to start implementing the CIDL. And the second step of implementing the CIDL is to specify some metadata. So here in the document, implementing the CIDL metadata, I'm going to copy this code and then explain. So here, in the CIDL metadata, we are specifying the CIDL specification version correlating as 0.8. And after that, we define the info object where we define the information about the contract, the program that we're going to be building, like the name here, informal lender, the title for this is for web-based documentation, summary, this is also for documentation, and the version of the contract and its license. There's some additional information that we can specify, but for now that is okay. Okay, going back to the document, now I'm going to the next step, implementing the types. So here I'm just going to copy the code and go through it, and you can do the same thing. Okay, so here I have defined the type. So basically the structure, as you may know already, what is a Solana account, this data structure types, how you want to name it, are going to be transpiled to a Solana account. So this will be the data structure of that given account. Here we define the name for reference. After that, I can specify some summary for the documentation, and here I specify the fields of my property. So the responsibility of the broker account is going to exist one per account. So it's going to be a per program, sorry. It's going to be a PDA account where it has the seeds only broker. So when it get created, it's going to only exist one time for that given program. And here I'm going to store a property named delegate. So basically this will be the address of the lender wallet, and this way only that user can authorize certain transactions and certain instructions. After that, I'm going to define a property for my capital to store how much money I have available to lend. Then I'm going to have another property to track down how much money how we have lended. After that, I'm going to track the revenue and the fee that I'm going to apply. So here my business logic is that every time a borrower makes a payment into a loan, they will need to pay a small fee that I have decided here. And here I can specify also description documentation to each property. And here in the CIDL generated documentation, we're going to get the web-based documentation. We just need to add the methods before this generates. And now explaining the loan data type. So for this program, we only have two types, brokers and loan. Here is also a PDA account. It's a little bit more complex on the seed definition. So I also have a static seed. I will track down the user that requested this loan. So basically this client seed is going to be the address of the wallet for the given user where the funds are going to be transferred to. And then an index, so basically one person can have multiple loans, so that's what the index represents. And after that, I define the fields of this loan data structure. Here I have the client property is the same as the seed here. And the purpose of defining this is for querying data after we have the account. Is a little bit easier that way. But it's up to you to put it there if you want. Then I'm going to have another field where we have the amount. So the amount of the requested amount for the loan. Then we have the pay. So how much money the client has paid after the loan has been approved. And here I'm going to store the KYC URL. So this is a really important legal part, and it's based on different countries. So before lending money, you need a lender or a bank needs to do some know your customer research. So it needs to check who is going to be borrowing the money for different reasons, and this can be the reasons can vary for country to country. So just keep in mind that for this type of use cases, this is really important because otherwise you can get into legal trouble in your country. Here, for simplicity, I've just put a URL and abstracted the entire process of a KYC, but here is for reference. And after that, here I specify the fee of this loan because it can vary. A given moment, I can start with a fee for, I don't know, 10%. It can be maybe absurd, but 10%, and then in another moment I change my broker fee to 20%. So new loans are going to be based on those fees. So that's why we store also the fee to the loan. And finally, we have the approve field. Is a boolean, so here is the lender that needs to approve the loan, and this manual state is because the lender, the organization needs to go through the KYC process and verify that the person everything checks out basically. Okay, so After that, we have basically two data structure, broker and loan. The next step is to define the method. So how these data structure are going to change data behavior over time. And for that, here in the document, I'm going to implement in the method section. Let me get a little bit of water. Perfect. So here I'm also going to copy the methods, and most of the things that I'm saying here in the workshop is also in the document. Okay. And let me collapse and just go through each one. So our first method is an array of object, and here we have our first method is named create broker. So this method is responsible of initializing the broker account in the Solana blockchain. Here I specify the summary of my create broker, and after that I specify the signers, I specify the fee payer, and I specify that the delegate needs to sign. So remember, the delegate is going to be the wallet of the lender that is going to be basically creating this program for the first time or deploying it. And I specify that this lender is going to be mutable to through the attributes, and it's mutable is because we are going to debit from the delegate accounts and credit the broker. So we're going to transfer from delegate to the broker account, and this way is that we are going to be adding funds to the broker, and that way the broker will have money to lend. After that, I specify the broker account and I specify the init attribute. So this is going to tell the generators to generate the code to initialize the account. Maybe you have saw this as a CPI call to the system program create account. So this attribute is going to generate all that code and it's going to initialize the account. Finally, I specify amount and feed. So these are data inputs and are required so to the for my business logic. The amount is going to be the amount of capital that I'm going to put to my broker. It can be 0, and here I'm going to specify the feed. Following that, I define another method, add capital to broker. So it's going to follow the same style, fee payer, the delegate from whom I'm going to debit the souls to transfer to the broker. And this method is to add additional capital in the future to the broker. After that, I have request loan. So this method is intended for the borrower, for the clients of the lender, where they're going to request a loan. They need to, there will be a fee payer, there is going to be a client, there is going to be a signer. So they need to sign the transaction. And here we have the loan account, the data structure that we defined above. Here we specify the init attribute again because I want to initialize this PDA account, and I specify the seed. So here, if we remember, the loan account has a seed name client. So this seed client needs to be the address of the wallet. And to achieve that, I need to link the client input to the client seed. And that way the generator is going to know that this input that is in account is going, the address of the input is going to be used as the value of the client for this PDA. That can be like a little bit complicated to reason about, but that way we can assure that the address is being correctly used for that PDA. After that, I specify the broker. In each account for request, loan, approved loan, and pay loan, we need a broker. And here I specify that, and finally I specify the amount that the borrower wants to borrow and the KYC URL. So then in my review process as a lender, I can get that information. And finally, we have the approved loan. Next, we have the approved loan. So this method is for the lender. Again, we have the fee payer. Here we have, again, the delegates. In the delegates is the wallet of the lender. Again, we have the loan is going to be mutable. And we do the same match. We get the client. In this case, it's also an account and it's going to be mutable. And finally, the broker. So why I have defined this way. So delegate is the lender wallet. We need to pass it because we need to verify that the account who created the broker and is going to be lending the money is the correct account. Otherwise, someone can pass and any account and drain some souls from that, and it was not intended from the broker. Here I pass the loan that I'm going to be approving as a lender, and I'm going to modify it, so I specify that it's mutable. Again, I specify the broker because the broker is basically this administration account that is going to be in all the transactions of the lender and borrower use case of this DeFi, and I need to use it for business logic. And after that, I specify the client account. So the broker is going to transfer, if the loan is approved, it's going to transfer funds from the broker account to the client account. And this way we have lended the money to that given client. Finally, we have the pay loan. So this method is for a borrower to pay a given loan. They need to specify the client wallet, and it's going to be mutable because we're going to transfer money from the client to the broker. Here we have the loan to verify to which loan this to check and which loan the client is paying, and also because the loan is attached to the client. Again, we have the broker and the amount. Finally, after we have defined the CIDL, we are ready to generate code. So gist of the CIDL, we need to specify some metadata. This can be up to you. We need to specify the data structure if applicable. So types can be optional. There are some use cases that are not needed, but in this case we have two. And here we can specify as much types as we need, and the fields. We specify the seeds to indicate that this data structure is going to be a Solana PDA account. If we don't specify the seeds, this is going to be a non-PDA. So what we know that's a wallet with the caveat that it's going to have a data structure. And after we have defined the types, we only need to define all the methods that we need and specify the inputs and all that. And here, if you click CIDL generate documentation, you're going to open the web-based documentation where the entire CIDL content, you can see it in a more UI UX friendly way, where we have the types. We have here all the information about it with all the documentation. So this documentation is coming from the description that we specify to the fields, or the summary to the types and methods. So here we can see that information, and also for the methods. So here we can see it in a much pretty way. Okay, so going back, after we have the CIDL, we need to generate code. To generate code is with the following command, but before that, you need to log into the Código CLI. So to log into Código, you type Código, login, and let me just show you logout. Okay, I was already logged in, so I had to. So you generate code, you are going to get a link. You need to visit that link, and then after that, you need to paste the code in the page that you open and authorize the Código CLI. After that, you're going to get a login successfully message where it indicates that you have logged successfully to the Código CLI and you're ready to generate code. So let me give 30 seconds for everyone to do that, and that way I can get a little bit of water. Okay. Also, you can download the Código CLI to your local environment and you can work from your local environment. I'm going to share the link at the end of the workshop, but you're not restricted to this web-based environment. You can also do it locally. The plus side of the web-based environment is that you don't need to worry about installing the Solana dependencies, installing Anchor and all that. It's just a link you enter on and you can start quickly working on it. Okay, so to generate code, here in the documentation is the next step, generate code. If you know Visual Studio, you go to terminal, new terminal, and it's going to open that. And finally, we need to type the command Código Solana. And if you type the flag help on the Solana command, you're going to get information about it. So also there is a shortcut. And here Solana has the generate. So we can see available commands for the Código Solana command is generate. And also on the generate you can ask for help and you're going to get all the documentation of the Código Solana generate command. So here we can see that we can generate the contract for Anchor. We can disable diff. I'm going to mention what is that at the end. You can generate only the client or only the program, and you can also specify the output of the generated code. But to generate here, I'm just going to type Código Solana generate and pass my CIDL file that I just created. And here in a few seconds, we have generated the code. We can see the logs. And if we go to the file explorer, we can see two directories, program directory and program client. So in the program directory, we're going to get the Solana program in native, and in the program client, we're going to get the generated TypeScript client library. The client library is 100% generated. We don't need to modify nothing. We just need to use it, integrate it with our application. On the program, we only need to implement business logic. So on the generated part of the accounts, receiving the instruction and all that, we don't need, and doing the preprocessor, we don't need to do that. It's generated for you here in the generated directory. I'm not going to go over that. You can check the code. It's recommended that you don't modify it because then you can introduce some security bugs or bugs in general, break things. After you generate code, the only thing that you need to do in the Solana program is to implement business logic. And for that, let's go to the documentation, implementing business logic. Here, you can see that in the source directory, you're going to get a file for each method that you define in the CIDL. So in the CIDL, we have create broker. Here we have the create broker file. And here we're going to be implementing the business logic. So our first implementation is the create broker. Let me copy this set of code. So I'm going to create broker.rs file, and all this code was generated for me. Here we have a function with the same name that we define in the CIDL create broker, and it receives the inputs that I define the CIDL. So here in my CIDL, I define delegate, broker, amount, and fee. I have that delegate, broker, amount, and fee. The fee payer is now passed to my stub because I didn't ask for it. And also I will always get the program ID to my stub in case you need it for your business logic. So this program ID corresponds to your program address. And the broker is a PDA account. You're going to see that it's wrapped with this structure named account PDA. So as you know, in Solana, we need to deserialize and serialize the data of a given account. With Código, that step is taken care for you. You don't need to worry about that. So basically with the account, with this wrapper, you're going to get a deserialized data of the broker data structure, and also you're going to get the broad info. So if we type the business logic here, you can see that I'm accessing broker.data. So broker.data, and when the intelligence completes here, you're going to get it. So here you will be accessing the broad fields, the deserialized fields of the broker: delegate, capital, lender, revenue, and fee. You can access that through the data. If for some reason you need the info, like in this case, here we have, I'm accessing the broad account infrastructure of the account of the broker. You can also have access that, and here you have access to the key property, to the LAMP, to the broad data information, and all the information that comes with the account info data structure. And quickly explaining the business logic for the create broker. Here I'm assigning the delegate of the broker. So remember, delegate is always the wallet of the user that is creating this lender program. Then we have the capital, so what the amount of capital that we're putting to the broker to lend. It can be zero. Then we're zeroing out the amount that we have lended, the revenue. Finally, we are assigning the feed input to my feed data, and you can have more complex calculation and business logic here, like a pure broad. You don't need to worry anything about Solana. This is your business logic. And finally, I'm going to transfer my Lampers from the delegate, from the lender wallet to the broker, and broker is a PDA. So here with this sugar syntax, I'm going to be doing that. Finally, I'm going back, the next step, going back to my documentation, implement a capital broker. I'm going to copy also that business logic, and it's basically the same as create broker. The difference that I only add in capital, and you may notice that there is a missing method to update the feed. You can do that as an exercise to understand a little bit more about the CIDL and how things work. Then we have implement request loan. So here the business logic gets a little bit interesting, but it's really something small, and it's just adding an if check. With the CIDL, implementing business logic is really simple. Like, you abstract everything about the contract and you focus on what really matters. There is a comment on some of the implementation, like for example, for this implementation, you need to add in line 10. It doesn't need to be exactly in line 10, but the point is that you need to add this import. So I'm going to copy that and paste it here in line 10, but it can be in line 4 if you want. Just be careful of not duplicating it. And this is just going to import my data structure for my enum for the informal lender errors. Okay. So here the interesting logic of when requesting a loan is to verify if my broker has capital to lend. Otherwise, I cannot lend money that I don't have. And I'm basically checking that by subtracting the amount requested to my broker capital. And I use a special function, saturating sub. And this is because the capital is an unsigned number. And this is just programming in general, computer science general, that if you subtract an unsigned number with another unsigned number, it's not going to give you a negative number because it's unsigned. It's going to give you a high number, and we don't want that. We want to verify if it's zero, but still maintaining the unsigned feature. And basically, this method abstract all the complexity of that calculation, and I only need to verify if this calculation that Ross is going to do with this function is less or equal to zero. If it's less or equal to zero, it means that the broker doesn't have enough capital to lend, and I'm going to return an error indicating that there is an invalid instruction. And we can expand the return errors for more meaningful messaging to the client, but for now we keep it simple. If the broker has capital, then we proceed to specify to initialize the data of the loan account. So here I specify the client to where we're going to be transferring the funds, then the amount, the paid, and the KYC. feed and approve equals false. This is important. The loan hasn't been approved. So that is going to be the next step. And here, implement approved loan. We have that. And here we have a little bit more of business logic. So I'm going to my approved loan. I'm going to replace my implement your business logic with the code I just copied, and also implement approved loan require this import. So I'm just going to copy that. And here you can see immediately the intelligence of Rose Analyzer has done all the indexing. So now I'm getting feedback. You can also do the quick fix from here, and it's going to import it for you. And it should be there. Okay. So here, my business logic again, verifying that the broker has capital to lend. After that, I'm going to check if the delegate corresponds to the broker. So I need to verify that the user that created the broker is the person authorized to lend the money. So basically the lender is the same one. So that is what we're doing here, checking that the lender corresponds to the person that is trying to approve the loan. If without this check, then anyone can approve a loan, and we don't want that. And after that, I'm going to verify that the client is also the same. So we need to check that we are going to transfer the funds to the correct loan. If without this check, anyone can pass an account to a loan that is going to be approved and get funds that they never request, and most likely they will never pay. So this check is to verify that it's the same person that we check through our KYC. Finally, here I'm just going to update my broker. I'm going to subtract the capital of my broker. So I maintain my broker up to date, and we never lend more money that we don't have. Then I'm going to increment the amount of money that I have lended. I'm going to indicate that the loan is approved, so changing that state to true. And finally, I'm going to transfer the funds from my broker. Remember that the funds are in the broker account, the PD account, to the clients, and here the client is going to receive the funds. Finally, on my business logic implementation is implement pay loan. Okay, so here I copy that, go to pay loan, and replace my implement your business logic with my code. Here we also need to import. Visual Studio Code is going to give you the quick fixes there, so we can apply the quick fix, but remember that the documentation states that you need to add the import there. Okay, so, and here I need to do another import, and quick fix, import Solana. Okay, so here I'm just checking that the client is not paying more than the loan, so that will be unethical to allow a client to pay more money than they borrow. Then we calculate the interest. Here is a simple calculation for production. It may be more complex for a interest financial of a loan, and also you need to be aware of the precision of a floating point number. So all those things need to be considered before a production use case like this. But for this workshop, we keep it simple and don't worry too much about the precision of the interest. After that, I'm going to update my broker data revenue. Here indicating that I have earned this amount of interest. Then I'm going to indicate the capital, so how much the return capital. Then the lending, I'm going to indicate that I have less money lended and I have more capital to lend. And after that, I indicate the amount of money that has been paid to the loan. And finally, I just need to transfer from the client wallet to my broker account. So here I specify that and I'm just log some information. And we have basically completely implementing the business logic. Another method that is missing is that me as the lender, I want to extract the revenue or maybe the capital. We can implement a method for that and start to expand the use cases. But for now, we leave it as that big of implementing business logic. The next step is to build and deploy the program. And just a quick note, if you're working from your local environment, you have the latest Solana version 1.17 something, there is a breaking change in one of the Solana dependencies where you're going to get an error from hash 1 something. So basically you only need to add this dependency to your cargo.toml. Here you can see the image, how does that looks, and it's going to be fixing the issue. Here I also left the documentation, the report to that issue, where basically the solution comes from there and you can read more about it, and it's an open issue. Okay, so after we have completed implementing the business logic, we can proceed to build the contract. And a quick note, the flow here in the workshop is like a continuous line, most likely implementing a use case for the first time or from a template for you. It's going to be an iterative process where you can need to be regenerating code. So you can go, proceed, and type the command to generate code. You're not going to lose your business logic. It's just going to put a div indicating that this is the new thing and this is the old thing, and you need to decide what you want there. But basically, you can regenerate code as much as possible as you need. Okay, and to build the program, you will be accessing the program directory and typing the command cargo build SBF, and that is also in the documentation. So here, cargo build SPF, you're going to get an output like this. And I don't build the program here live because it's going to take around 5 to 10 minutes. The compilation is a little bit slow. I have already built the program here in my DeFi directory. I have the same program. So I'm going to access that CD DeFi program. It's already built. And I only need to deploy the program. So after you have built, the next step is to deploy the program. We also have that. You need to run the validator in case you want to do it locally, or you can also deploy to DevNet or testnet or mainnet if you want. I'm going to run my Solana validator here by typing the Solana test validator. I'm going to specify the R flag. This is just going to reset my validator in the test ledger. That way I have a clean validator and don't encounter any type of issue. I'm going to run that. I'm going to, here it has started. In the web-based environment, do things like a comment, do things step by step. Don't run the validator and build the contract at the same time, because it's a web-based environment with certain amount of limited resources, and the Solana validator takes a lot of resources, plus the cargo, the big compilation step of the contract is also going to take a lot of resources. So you can hit the resource limit and your process is going to be killed. So just do things step by step. Okay, so after we have built and we have running the validator, the next step is to deploy the program. So here I'm going to type the command Solana program deploy, and then the file is in the target directory, deploy directory, and here I have informer lender.so, and the name of this file comes from the info .name. So the name that we specify here is going to be used for the name of this file. So let's say I put here DeFi, then this file is going to be defi.so. And I'm going to press enter, and this is going to deploy my program to my local validator. Here you can see the program ID, so keep in mind, copy your program ID so you can use it for the integration of the client. Okay, so after building and deploying the program, we need to integrate the client. Let me copy this program ID here so I don't lose it. Give me a second. Okay. Let me quickly refresh the page. So as I mentioned, the Solana validator consumes a lot of resources and it killed my environment. It's going to come back quickly. Okay. So it's back online. So the final step is to integrate the client, and I'm going to be creating an app.ts file in my program client directory. In a real world scenario, you're going to be integrating a program client with your web application or Node.js API. And here in DeFi program client, I have already created the app.ts file and I have integrated. So here we have all the code. You can copy the entire code. So here, and the important part of copying this code is that here you need to paste your program ID. So remember to do that. I have already pasted my program ID. And this program ID, remember that is the one that you receive when you deploy the contract. Finally, I can run this app.ts file and validate that everything's working correctly. And going through quickly, I'm just going to create some wallets to represent the lender and the borrower's wallets. In the real world scenario, most likely this wallet will come from Phantom Wallet or any other provider, or also custodial wallet. So basically, this represents a custodial wallet. And here I have created those wallets into the Solana blockchain. And then I'm going to call my create broker send and confirm. So for each method that you define here in the CIDL, you're going to get two functions in your client, one named create broker, and that is going to return what is the transaction instruction. And after that, create broker send and confirm, that is going to create the transaction instruction and also send the transaction to the blockchain. And here I only need to specify the inputs. And these inputs that I need to specify come from the inputs that I define in my CIDL. And if there is a signer, I need to specify a signer. Here I just check that if the broker doesn't exist, that way my client doesn't crash if I rerun it. And also for each type that you define here in the CIDL broker and loan, you're going to get a headers through which you can retrieve the account of the blockchain. Okay, so here. After that, I'm just going to request a loan, approve the loan. Then I'm going to request another loan and by another client. I'm going to approve that. Then here I'm going to request a third loan, but in this case, the contract is going to return a error because it doesn't have enough capital to lend. So this way I can verify that that feature is working there. And finally, I'm going to start paying the loan and getting my account back. Okay, so for that, because I had to restart the validator, the page, sorry. Let me restart my validator. Run a test validator. It's going to initialize and let me navigate to my program client directory. Okay, here it has started and there I lost the connection. So basically you're going to get the final output where you're going to see this. I'm just having a little bit of issue there, where you're going to get the broker state, the client one loan, and all the information how it has going been. Uh, so basically that's the workshop. Everything that I have mentioned here is in the document and also in the Discord. You can ping Sohan on me to ask additional questions also with the Encode team, and there we can help you with anything. So now we have around 8 minutes to 7 minutes to take any questions. So if Sohan, let me see where I got the questions. Okay, let me see. Okay, so and let me stop presenting so I can see. So the first question, does Código use language model to generate this stuff? Initially, we started with LLM, but we immediately noticed that, and as you may know, LLM are not suited to generate complex projects. They can help you with generating a part of the business logic, a simple function, and things like that. So we implemented an internal algorithm to generate the code in a deterministic way where you're going to get the same code with the same CIDL. This way we can guarantee that the security checks are there and are verified, because an AI can miss the one security check in one portion of the generated code, and in another they add it and things like that. But in the Código roadmap, we're going to be adding AI to help you try to generate the CIDL from the AI, because it's easier to go from a natural language, from an interface, to a complex project like a Solana program. But with an AI, we can tell, okay, I want these types, I want these methods, and that way you can have a secure and production-ready contract program, but without losing the capabilities of a AI. The other question, let me see. So the other question, why are we writing the contract in YAML instead of writing it in a programming language? So we're using an interface definition language or interface description language. Is the same. So here, basically, this type of technology is an intermediary between programming language. Each programming language can be different. So here we only need to specify the interfaces and the methods of that, basically the API of the contract. Maybe you know it in other blockchain as an API. So that's after the process of compilation has done. IDL is the initial part. So we use the YAML to specify the information and to maintain everything simple, because we only want to express the interface. With a programming language, we need to add a lot of things, and also a YAML file is a syntax that basically every developer knows. So a developer from one blockchain can come and use another blockchain with the same CIDL, and then they don't need to learn or understand all the internal parts of a specific programming language. So also this IDL reduce the learning curve of Solana, because besides, as we know, learning Solana is really complex, because you have the learning curve of Rust and then the learning curve of Solana. With the IDL, we reduce that learning curve, because you don't need to be an expert in Rust to try to write a program. You don't need to worry a lot like about the borrow checkers, lifetime, things like that. You only concentrate on your business logic, and that's really simple. Uh, so hi, I'm receiving an error when introducing the code.yaml command. It says fail verifying if the CIDL file exists. So as the message indicates, is that is the path that you are passing to the generator is the incorrect one, or the name of the file is incorrect. So here, I don't know if you copy literally, but you have called. If you name your file CIDL, then that's a typo there. So just verify if the file name is correct. So Is it due to a large resource consumption in Solana test validator? The connection is lost and the terminal is booted. Yes, so basically in the environment we have for the moment 4 GB of RAM for each environment. So Solana test validator can go beyond that sometimes, and that's why you get the reboot. Most likely we're going to increment that. We're just like collecting data to see what is the sweet spot for the resources that developers require. And also we're going to be checking other way of the Solana validator. But if you don't run the Solana validator, you will not have any type of issue. And also you can deploy to DevNet and you will have the same experience. So any plans to have blueprints for reusable components that can be immediately used with Código in order to accelerate even more dApp development? So yes, that part of the product is named CIDL registry or CIDL hub basically. We are going to create a portal, a website where you will have access to multiple use cases created by us, by Código, but also you as the part of the community will be able to publish use cases, and this way other developers can start from those templates, but also they can import those CIDLs in their own. So that's a part that we didn't cover in the workshop, but you can import other CIDLs in yours to expand the use cases, and that is going to come basically for the Q1. Okay. So will Código also have a front-end part? So in addition to the program and client library, we also have a scaffold project for say React or Svelte. We are in the talk of that. So each developer or team can have a little bit of decision on how they want to create their React or Svelte project. Someone would like to create a React app if I say the command correctly. Others want to use Preact and things like that. So there is still some investigation. What are the most common things that the developer is using? So the last question, because the time is up, will Código offer fuzzy testing for auto-generated tests for at least the program part? So yes, if you go to the generated code, you will see a test directory where we generated a little bit of tests for the program part. This is going to be expanded in the year, so you will be able to run the test from the program or from the generated client library, and here you will get all the test cases for each of the method that you define. So you will be able to verify if your transaction is returning okay, or if it's returning, if the security checks are working as expected, and things like that. And also in the generated web-based documentation, you will be able to run the test from there. So from a UI, you don't need to touch the terminal and things like that. You will have a more UI UX friendly experience for running that. So thanks for participating in the workshop. I hope that is really helpful and like you enjoy your journey here learning Solana blockchain with Encode and here with Código. If you have any question, doubt, you can pin me in Discord, and the Encode team is also there for help. You can also ping Soham, and we are more than glad to help you to start this journey in the blockchain in Web3 space. The final part is to remember to follow us at Código platform in the X platform. We're going to be releasing a lot of features in the following month and in this year. The CIDL that you just saw is going to get more easier, less verbose, and more use cases. We are also creating an assistant, so an LSP for the Visual Studio Code plugin, where you're going to get immediate feedback while you're writing the CIDL, auto-completion, and basically the full capabilities that we know in programming language. You're going to get it with the CIDL. So remember to follow us on Código platform, on X, and also on Discord, and the Encode team. Thanks.
Thank you, Hasil, and I hope you can all join me in offering thanks to Hasil for what was an absolutely wonderful, wonderful workshop there. Participants in the Solana Hackathon, I hope you can join us tomorrow for our next workshop on creating inscriptions in Solana. But yes, thank you, Hasil, that was wonderful, and we will hopefully see you all very soon. Thank you.